Hello everybody. In this video, I want to demonstrate to you steps on how to solve problems using Coulomb's law to find out the electrostatic force between the charged particles, which is we talked about in lecture number 2. Say that we were given a problem that provides us the charge and the location of two charged particles. Q1 located at x1, y1, and Q2 located at x2, y2, respectively. We can apply the following 5 steps to calculate the electrostatic force that charge Q1 applies on charge Q2. These steps are, the first one is trying to sketch the locations of these two particles in the coordinate system. These sketches will be very helpful to visualize the problem and also will help us to check our answers after we solve the problems. Once we sketch the problem, we can try to find out the vector that's starting from Q1, the location of Q1, and end at the location of Q2. This vector is denoted as R12, which is as the vector here, starting from the location of Q1 and at the location of Q2. Then we can calculate the distance between the two charged particles from this vector, which is basically the magnitude of this vector R12. And we can also calculate the unit vector of R12 hat, which is basically the vector of R12 divided by the magnitude itself. This is the direction that's pointing from Q1 to Q2. The next step is try to calculate the magnitude of the electrostatic force using Coulomb's law, F12 equal to K Q1 Q2 divided by the separation of these two charged particles squared. Remember that it's squared. Once we know the magnitude, we have to determine the direction of the force. For that, we have to know the polarity of the charges, which is basically the signs of the charges. If the two charges have the same signs, so that means they are both positive or they are both negative. So that means the force will be repulsive force. That means Q1 would be repelling Q2, so it pushes away from it. Then that means the force F12 will be in the same direction as the R12 had. Therefore, we can write down the force in the magnitude and the direction format. The magnitude multiplied by its direction unit vector. So the force's magnitude is calculated in this way, and the direction of the force is in the same direction as R12 hat. So this is the magnitude multiplied by the direction vector. If the two charges have opposite signs, that means one of them is positive and the other one is negative, then the two charges will attract each other. In this case, the Q1 will attract charge Q2. So it will pull the charge Q2 towards Q1. That means the force will be in the opposite direction of R12. So we can again write down the force vector by its magnitude multiplied by its unit vector, because the force is in opposite direction as R12 hat. So that F12 should equal to negative R12 hat. That's how it comes here. Let's look at the example that we did in the lecture. In this problem, we were asked to find out the electrostatic force that's the charge Q2 and Q3 on charge Q1. Let's follow the steps one by one. First of all, we sketch the problem by drawing the locations of these particles in the XY coordinate system. Let's try to draw the XY coordinate system first. This would be x-axis. This would be the y-axis. And now we're going to draw the particles. Particle charge Q1 would be on the x-axis at x equal to 8 micrometers. Let's just draw it here. 2, 4, 6, 8. Say this will be Q1, which is located here. And the charge Q2 will be on as the origin of the coordinate. This will be charge Q2. And the charge Q3 will be on the y-axis at y equal to 6 micrometers. 2, 4, 6. This will be Q3. And we also note that the charge Q1 is a positive charge, charge Q2 is a negative charge, charge Q3 would be a positive charge. So in order to find out the net force that's applied on charge Q1, that's basically F net. You need to use the superposition of the two forces. The first force is the charge Q2 applies on charge Q1. That's going to be F21 plus the force that charge Q3 applies on charge Q1 is F31. We will apply those 5 steps to calculate each of those forces. All right. So the first one is the force that charge Q2 applies on Q1. So F21. All right. So in order to find out the force of F21, we need to find out what is the vector. That's the point starts from the location of charge Q2 and end at the location of charge Q1. This will be R21. So R21 should equal to the x-coordinate of the charge Q1 minus the x-coordinate of the charge Q2 I hat plus the y-coordinate of the charge Q1 minus y-coordinate of the second charge J hat. And because Q2 is as the origin of the coordinates, so x2, y2 are both equal to 0, then I will skip the math a little bit. So this will be giving us 8 micrometers I hat. So we can verify that R21 is pointing to the right along the positive x direction. This is correct in the positive I hat direction. So the magnitude will be the distance will be 8 micrometers. All right. So then the force F21 should equal to just K Q2 Q1 divided by R21 squared. So the magnitude of R21 vector, which is R21, is going to be 8 micrometers. And the unit vector would be the vector itself, R21 vector divided by R21, which is going to be 8 micrometer. I hat divided by 8 micrometer, we get I hat. So replace the values. K is 10 to the 9th power multiplied by absolute value. The charge Q2 will be negative 20 nanocoulomb, will be negative 20 times 10 to the negative 9th. Then multiplied by the magnitude of the charge Q1, which is 10 nanocoulomb. If I write everything here, all the parameters in the SI unit, the final unit for the force will be newtons. So the R21 will be 8 micrometers. So this will be 8 10 to the negative 6 meters squared. And after that, we can calculate it. This will be, we did this in the lecture. This will give us 2.8, approximately 10 to the 4th power of newtons. Now we find out the magnitude of F21. So we have to determine the direction of this force. We see that Q2 is a negative charge, Q1 is a positive charge. They have opposite signs. So the force between these two particles should be attractive force. So it should be Q2 should be attracting the charge Q1, should be in this direction. This will be R21. It should be in the opposite direction of the R21 hat. So the F21 hat should equal to negative of the R21 hat, which is negative I hat direction. Therefore, we can write out the force of F21 in the vector form. It will be 2.8 10 to the 4th Newton multiplied by the unit vector. This is negative I hat. We can simplify it by 2.8 10 to the 4th of Newton in the here. Okay, negative component there. Similarly, we can apply the same steps to find out what is the force of F31. F31. We write down this here. First of all, we need to find out what is the vector that's starting from the location of the Q3 and end at the location of Q1. Let's draw that. This will give us a different color. Let's see. Draw this here. We'll draw this here. It's from here to there. Alright, this will be R31 vector. So then we'll come back to here, R31, that should equal to x1 minus x3 I hat plus y1 minus y3 j hat. As you see here, if I write down the subscript in the correct order, we can easily figure out what we should do in writing this equation to find out the vectors. So 3,1 should be x1 minus x3 and y1 minus y3. So we can substitute the values. Y1 is 8 micrometers, and sorry, x1 is 8 micrometers, and x3 is 0, so there were 8 micrometers in the I hat, plus y1 is 0, and the y3 would be 6. That would be 0 minus negative 0 minus 6 micrometers. J hat, this will be 8 micrometers. I hat, not plus, subtract 6 micrometers. J hat. From this, we will know that the magnitude of R31 would be square of 8 micrometers plus square of 6 micrometers, then square root. 64 plus 36 will be 100, so square root of that will be 10 micrometers. The R31 hat, the unit vector, would be R31 divided by the R31 magnitude. So the x component would be 8 micrometers divided by 10 micrometers, 0.8. I had the y component divided by the 10 micrometer will be 0.6 in the j hat direction. So now the next step is trying to find out what's the magnitude of the force using the Coulomb's law formula there, F31. That would be K Q3 Q1 divided by R31 squared. This is equal to 9.0 10 to the 9th power multiplied by charge Q3 would be 5 10 to the 9th power multiplied by the charge of Q1 will be 10 multiplied by 10 to the 9th power divided by the distance, which is 10 micrometers, so it will be 10 multiplied by 10 to the negative 6 of a meter squared. This will give us 4,5 newtons. Okay, 4,500 newtons. Oh, forgot this power here is negative 9th power. All right. So the next step is trying to find out the direction of the force, because this Q3 is a positive charge. Q1 is a positive charge, so Q3 will repel Q1. The force is repulsive, so the force is in the same direction as the vector of the R31. That will be equal to R31 hat. This should equal to negative positive 0.8 minus 0.6 j hat. Now the force of 31 F31 vector should equal to the magnitude of the force multiplied by the unit vector of the force. That should equal to 4,500 newtons multiplied by 0.8 I hat j hat. That should equal to 3,600 I hat minus 2,700 j hat. So be in newtons. So now we find out F21 vector. We find out F31 vector. We can substitute this into here. F21 will be negative 2.8 10 to the fourth power newtons in the I hat. Then plus the F31 vector, the x component will be 3,600, will be 3.6 10 to the third power I hat with Newton, and subtract 2.70 10 to the third power j hat. So the I hat components will add up, negative plus 3.6, that will be negative 2.44 10 to the fourth power j hat, negative 2.70 10 to the third power. Oh no, sorry, this will be newtons I hat and the newtons in the j hat. Alright, that's a problem. Answer for the problem here. As you see that I follow those 5 steps to calculate the force of each charge on charge Q1. Alright, so hopefully this help you to solve the problems from the homework and help you to answer the questions in the group work problem.